OpenLink Data Twingler, CustomGPT. The conversation openers are presented by default, configured to at least let the user commence interaction easily. So in the most basic sense, for instance, a user should be able to request from this agent generation and execution of different query types. Write and execute a SQL query. And so you're going to see that right. And basically the very first thing it has to do is execute an action. And that action is executed against the URI burner instance, right? So that's, in a sense, that is our beachhead for this particular agent. And so what you're seeing right now is the result of a SQL query. And if you notice just now, there was a panel presented that allows you to see exactly what was executed. Now, naturally, you can also tell the agent you want alternative presentation of the query solution or the results. So here I've requested tabulation of those results, which is what's being presented. So I'm going to repeat that process, but this time for SPARQL. And so again, remember, by default, ChatGPT cannot execute queries at all. Only when you install this component does that functionality become available. So here's the result of a SPARQL query. And I can even tell it, based on the results, can you sort of tweak that, which will come up in a few seconds, tweak that query so that you have distinct names and birth dates. So I'm going to ask it to anchor the first names with a DBpedia hyperlink. And I'm also going to say, make sure I have a solution comprising distinct names. So as you can see, it remembers that my preference is for the query solutions to be tabulated. And so you get the solution presented in tabulated form. And it's also understood the fact that I wanted distinct names and I wanted a hyperlink anchored to each name. And so I'm repeating, well, I attempted to repeat a query in SPASQL, but it's kind of saying, well, I've already executed a SPASQL query. But the key thing is that it picks up the fact that a SPASQL query has a keyword SPARQL before, an actual SPARQL query whenever you're executing SPARQL from within SQL using a basic pattern. There are more sophisticated patterns that it understands, but for the purpose of the demonstration, I've kept it to the very basic pattern for SPASQL. And then I can tell it, okay, move on to a SPARQL fed query. And what it's now doing is using a combination of the URI burner instance and DBpedia, as you will see when we look at the code that was executed. So there's a code reveal. And so you'll see how the service keyword has been incorporated into the query that's eventually executed. And then I'm repeating, this time I'm saying create, generate and execute a sample GraphQL query. And it has to be reminded to tabulate because GraphQL's natural solution set isn't really in tabular form. And so I've just asked it to tabulate, and then there's a tabulation. And then we can see the actual GraphQL query that was executed. And now what I've done is say, okay, you know what, let's up the ante a little bit and say, here is a particular query. I want you to execute this query. And this query is the page that describes the Microsoft Loop application. So this is an example of using the web itself as just another relational database that you can query using SPARQL directly, or you can do so using SQL, where SPARQL is simply integrated into SQL. And so again, you get a tabulated solution, and you have a hyperlink denoting the different entity types that are described in that particular page. So I'm just going to go to an instance of an application, and it takes us straight to the Microsoft Loop page. And so this gives you a feel for how the power of declarative query languages extends to the web rather than being confined to, traditional relational databases or knowledge graphs behind an enterprise firewall.